All right, so we're going to continue with symmetry of functions, lesson 3.4. This is video number 2. So we were on this question here. We wrote the rule for the translation, and now we have to graph it. Now, since my rule says I'm going to move x to the left 3 and y down 2, since my asymptotes right now are centered at the point 0, 0, what I'm going to do is move the center of those asymptotes to the left 3, 1, 2, 3, and down 2. So this point right here becomes the new center of my asymptotes. So I'm going to sketch those new asymptotes. So those are my asymptotes. And then my new curves, I'm also going to do it in the same color, would look like this. So I've had to move my asymptotes from where they were in orange to where they are now in pink. The next question says, how does the translation affect the asymptotes? In other words, what are the new asymptotes? Well, I can look right here at my graph and I can see that my vertical asymptote is at x equals -3, and my horizontal asymptote is at y equals -2. And that's because my original asymptotes, I'm just going to show you that real quick. In case I didn't have the graph to look at, you've got to know how to do this algebraically. My original asymptotes were x equals 0, y equals 0. My translation said to move x -3 and y -2. So my new asymptotes, I'm going to abbreviate that, well, I guess I'll just write it out. My new asymptotes then, take the x and subtract 3, so I get x equals 0 -3 or -3. The y, I'm going to subtract 2, so I get y equals -2. Okay. My next question says, find any equation for asymptotes for the equation f at x equals 1 divided by x -4 squared minus 7. All right, my first step all the time is, what's my parent? My parent equation is 1 divided by x squared, and that graph looks like this. And my asymptotes, because the question is asking about asymptotes, for my parent are right here, x equals 0, and this horizontal line here, y equals 0. So that's for the parent. Then I've got to figure out my translation. Translation, which is so important. All right, I look at my equation. X lies in the equation, so this is x -4, so it's going to be x plus 4. And -7, the y tells the truth, y -7. I could also write it this way for -7 as a subscript. So my new asymptotes are going to be, I'm going to add 4, so I get x equals 4, 0 plus 4, subtract 7, y equals -7. So there we go. Great. Let's go down to our next example. This is the example 2 on the back here. Prove that the graph f of x equals 10 divided by 3x squared plus 1 is symmetric to the y-axis. If you are symmetric to the y-axis, if you remember from our notes earlier, those were my even functions, and that meant that my xy became opposite of x, y. Remember, the y doesn't change, it's only the x that changes. In order to show this, in order to prove this, I need to show that f of x, which is the original, is equal to f at the opposite of x. Now, when you're doing a proof, you have to do the left side and the right side separately, and then show that they're the same. The left side of the proof says, just tell me what f of x is. Well, that's easy. It's 10 divided by 3x squared plus 1. Okay, so that is going to be f of x. I have shown that. I have shown that the left side is simply 10 divided by 3x squared plus 1. Now I need to show what f of negative x is. All right, 10 divided by 3, I would substitute in a negative x there, squared plus 1. So notice, negative x, negative x. Got to keep solving here. 10 divided by, when you square a negative, it becomes positive, so I just get 3x squared plus 1. Well, look at this. F of x equals 3x squared plus 1, and f at negative x also equaled 3x squared plus 1. All right? Since they're the same, I have proven that it's symmetric to the y-axis. So let's talk about even versus odd. Okay? If a function is even, that means that x, y is going to reflect and become opposite of x, y. It means that the function f of x equals f at negative x, and it means that it is reflection symmetric over the y-axis. So if you are going to prove that something is even, you have to do it one of these three ways. Those are your only choices. You can't say, it's even because it has an even exponent. That is not a proof. The only way to prove that something is even is you're going to have to use one of these three as your proof. Odd would be that your x, y changes to opposite of x, opposite of y. That f at negative x is going to equal opposite of f of x. So you're going to, when you substitute in a negative for the x, you get a negative for the whole function. That's opposite of x, opposite of y. Or that it is rotation symmetric 180 degrees around the origin. So this one right here, these two, we're going to use when we have a graph. So I can look at this quadratic right here, and I can see that it's reflection symmetric over the y-axis. So I can say that this is even because it's reflection symmetric over the y-axis. Sorry, I didn't know that wasn't in view. Now, I can't just say because it's reflection symmetric. I have to say reflection symmetric over the y-axis. That is what makes this graph even. This graph here is odd because it's rotation symmetric 180 degrees around the origin. There is no other way that I can show that this is rotation symmetric. I can't simply pick one point here and show that that this rule up here applies. I would have to show this for every single point on the graph. So the only way with a graph is to say, talk about its symmetry if you're speaking about even or odd. This next question here, it says to prove that the function is odd. If I want to prove that it's odd, I look over here at odd. This is my odd test for equations. So use for equations. All right, you would use this for equations. All right, so my odd test is f at negative x equals negative f of x. I have to do each part separately. So let's do this part. F at negative x would be 4, I put a negative x in there, minus 2 and a negative x, and I would cube it. So let's simplify. Positive times a negative becomes negative 4x. Then I have minus 2, and negative x times negative x times negative x is negative x cubed, because a negative cubed is still negative. So I have negative 4x, a negative 2 times a negative x cubed becomes plus 2x cubed. Now let's do this side. Negative f of x means negative of the whole thing. So I'm going to distribute the negative, and I get negative 4x plus 2x cubed. You cannot skip this step. Without this step showing that you put a negative in front of the whole thing, you don't have a proof. This is the same as this, therefore it is odd. Now we're asked to prove that something is even. So since I'm going to prove that something is even, I have to use the even equation test, which is f of x equals f at negative x. Right, I've got to do both parts of the proof. F of x simply equals 7x to the 4th minus x squared. That's all I have to do for the left side, is write it down. For the right side, I have to do a little bit of work. I'm going to take 7 times negative x to the 4th minus negative x squared. I have to show my substitution. Then I'm left with, when I take a negative to the 4th power, it becomes positive. Minus, when I take a negative and I square it, it just stays x squared. So these are the same, therefore this is even. Alright, so just to summarize on these two tests, the even test is easier because there's nothing to do except copy the equation for the left side. The odd test, you have to do substituting for both the left and right side of the test. What I have shown here is the minimum you could show. You cannot go from this first step all the way down to here. You can't just say that this equals this. You have to show this first step, which shows the substitution. That is absolutely necessary. Without these first steps, there is no proof. If you're going to prove that something is neither even or odd, you have to do both tests, and it has to fail both tests.